So do
Inside didn't send the video for what we did last time.
okay, don't worry. We'll come back and cover that part after we're done with polynomials. So part one of polynomials, methods of division. So we'll start with long division. Okay, so we'll pick an example where we'll find a quotient and remainder. Of 1 of 4x power 3 minus 32 x squared plus 29x minus 7 when divided by 4x squared minus 4x plus 1. So we're using long division. So we'll say 4x squared minus 4x plus 1, and then you do this, and then you put 4x3 minus 32 x squared plus 29x minus 7. So you divide 4x squared into 4x power 3. So we're dividing 4x power 3 by 4x squared. So end up getting x. So we put x here. And then multiply x multiplied by 4x squared minus 4x plus 1. So we'll get 4x power 3 minus 4x squared plus x, and then subtract. So this one, it will just come down because there's no constant that we have. So 4x power 3 minus 4x power 3, we get a 0. And then we have minus 32 x squared minus minus, which becomes plus 4x squared. So we're going to do 32 minus 4, and then consider the minus for the answer because 32 is one that has a negative. So there we are getting a minus 28 x squared, and then plus 29x minus x, that's 28x, and then minus the 7 that just drops down. So now we divide again, 28x squared divided by 4x squared. So there we are getting, so it's minus, remember, so we're going to get minus minus 7. only. So we multiply, we'll have minus 28x squared plus 28x and then minus 7. Then we are subtracting. Everything comes out to be 0 because the first one 0, second 0, third 0. So we're saying the quotient as a function of x is x minus 7. And the remainder also as a function of x is equal to 0. And that's how you do the long division. So you would do that for all the questions under long division.
Ah,
Hello.
does there always to be 0?
No, you don't have to force it to be to what number. Yours is just to do the right thing. You do the multiplication, subtract, whatever number remains there. How you know that now I cannot divide anymore? When the power for this part, like since we are dividing by x squared, when the power becomes less than 2, then we stop dividing. So whatever we have there will be called the remainder, even if it is not 0.
Oh, okay.
So when it comes out to be 0, we call 4x squared minus 4x plus 1 as a factor. Okay? When the remainder is equal to 0. So it means that this guy is a factor of this dividend. If the remainder was just another number, I would have just called it a divisor and not necessarily a factor. So we got the next one. We'll do synthetic. Synthetic division. So do A, which is x power 4 minus 3x 3 plus 2x squared plus 5 when divided by x minus 1. So if I want to use synthetic, I go to the divisor and equate it to 0. Find x. Even if it was a quadratic, you solve for x. Even if I get 4 values of x, I just need to pick one. That one I pick, I put it here. And then, not that you pick the number 1, I'm saying you pick out of the x values, if they were 4, you would pick one x. And then now you get the coefficient starting from the highest power. So 1 for x power 4, minus 3 for x power 3, 2 for x squared. Because we don't have x power 1, we'll pick 0 for that. And then 5. If you don't pick 0, whatever you do down will be wrong. So the missing x power we represent by 0, because the reason why it's missing is because it's being multiplied by a 0. And then you drop down, you add the 0 to the first number so that it comes down, and then multiply 1 by 1, we'll get 1. Continue adding, we'll have minus 2. Add, you multiply there and then you add, you get 0. add, multiply, add, we get 5. The last number we get is the remainder. So we're going to have quotient. Since this was x power 4 and we've divided by x power 1, so this is the coefficient of x power 3. The following one is the coefficient of x squared. And then the other one was supposed to be 0x plus 0, the constant, with the remainder being 5. But there's no need of writing 0, so we just write it like this. So this is the quotient, and this is the remainder. So you see, the remainder is not supposed to be 0 always. It can be 5. Okay? So this was synthetic. We move to factorization. The question is factorize completely. One f of x is equal to 5x squared minus x power 3 plus 32x plus 36. So when when I want to factorize, I must first find a factor. How do you find a factor? Okay, how do you find a factor? You use a trial and error method.
We try.
Good. So start by trying 1. You substitute one where there's x and see if the remainder we're getting is 0. So we have 5 minus 1 plus 32 plus 36. This cannot be 0. So we substitute -1. We'll find 5 plus 1 minus 32 plus 36. So this also is not 0. So we try 2. We'll have 2 squared times 5. That is 20 minus 8 plus 32 times 2. That's 64 plus 36. So that can be 0. So we try -2. It will give us positive 20 here still. It will give us positive 8 here minus 64 plus 36. So we add. Here, what do you get? This looks like a 0. So 20 plus 8. Okay, let me do 20 plus 36. That is 56. 8 minus 64 is minus 56. So we get a 0. Okay. So when we get a 0, we go back and rewrite our function now as negative x power 3 plus 5x squared plus 32x plus 36. I want to use synthetic method, so I will get the coefficients like that. And then I'll put the number -2 here, add a 0, multiply, add, multiply, add. So 32 minus 14 is actually 18. Then multiply so that I get 0. Okay, so I can now write f of x as x plus 2, because it's a negative here. So it will be a plus 2 here, multiplied by, this was power 3 divided by power 1. So we're going to have minus x squared plus 7x plus 18. And so we factorize this again. So the product of this guy is actually equal to negative 18. And then the sum is 7. Making it a bit difficult for us. And again, very easy because the factors are clear that we are going to have 9 and -2. So if I put -2, I should get a 0. So if I want, I can carry on with synthetic division. Let me just demonstrate. So we'll have -1, we'll have 7, we'll have 18. The first one, the -1 comes down, you multiply, you get +2. Then you have 9 minus 18, you get 0. So this is going to now be x plus 2 multiplied by x plus 2, and then -x plus 9. Since the power was 2, this one reduces to power 1 and then to the constant. And this is how you would want to write it. If you want, you can say, oh, this is now x plus 2 squared multiplied by -x plus 9. You are factorized completely like that.
So, apart from finding the factor and what's this, the chow method, can't you factor using what's this grouping?
Polynomial.
Mm,
How do you group a polynomial? What?
like you find what's common here.
for a polynomial. A polynomial has only two methods of being broken down into the factorization, at least up to this stage.
Okay.
The grouping will confuse you and you hate it even more. It's better ungrouped than trying to group it. Okay. So now we move to the next one. Equations. Solve the following.
Sir,
Hello.
I'm a bit behind on how you're dealing
How we are?
with the powers.
Come again.
How you're dealing with the powers.
When
I'm
doing
saying I'm a
synthetic
bit
division.
behind on how you're dealing
Okay, I hear you.
with the powers.
So look. So when the power is 3 in the first place, and I divide by x plus 2. Now with synthetic, I equate this to 0 and get x is equal to -2. Now when I'm dividing, the power I've used to divide is 1. So if I divide by 1, it's like I'm doing x power 3 divided by x. The power becomes x squared. That's why after dividing, the power reduces from 3 to 2. And if it was power 2, it reduces to power 1, because if I divide the x squared by x, I'll get x power 1. That's why the power is reducing by 1 when we divide by x power 1. It's the same thing that we are doing here. If you look at what was happening here, when we divide 4x power 3 divided by 4x squared, the power was reducing following what you have used to divide. So this is the same concept that we are using in synthetic division. And then because we are not skipping any power, that's why even when correcting the answers, we don't skip a power. Look what I did here. I say because there was no x to the power 1, we had to put a 0. This 0 is there to help us not miss any power. When we come down here, since this was x power 4, we'll have x power 3, x power 2, x power 1, and a constant. If they're not there, then they'll have coefficients zeros. At least it would have shown that, oh, they were supposed to be here, until we get to the remainder. So the powers must not confuse you that much.
All right. Thank you.
Okay, so now we solve for x are given x power 3 minus x squared minus 7x plus 15 equal to 0. So we substitute 1 where there's x. We are going to have 1 minus 1 minus 7 plus 15. This is not 0. Again, we're using the trial and error method until we find one that will make this 0. We try -1. We'll have -1 minus 1 plus 7 plus 15, not 0. 2, 8 minus 4 minus 14 plus 15. This is not 0. Minus 8 minus 4 plus 14 plus 15, not 0. Interesting, eh? Let's go to positive 3. We have 27 minus 9 minus 21 plus 15, not 0. Then we'll have minus 27. If we use negative 3, minus 9 plus 21 plus 15. We try. This is negative 20. The other one is the, looks like this is a 0. This is a 0. Let me confirm. Negative 27 minus 9 plus 21 plus 15. Yeah, this is a 0. So I've gotten a 0 final. So once we have a 0, we check what number have we used? We have used negative 3. So we use this negative 3. Via synthetic, static is easy for me, and I think it should be for you as well. Because just pick the coefficients now. And drop the first one by adding a 0, then multiply. Add, multiply, add, multiply, add. Okay? So we're going to write this as x plus 3 multiplied by x squared minus 4x plus 5 is equal to 0. Then we factorize x squared minus 4x plus 5. So we're going to have x squared. We can use plus x. Oh.
Sir,
Hello.
so that x squared minus 4x plus 5, we can't leave it like that. It should be simplified also.
I'm trying to see if we can factorize it, but the factors have failed. I can't see factors here. So we'll just equate it to 0. So we're going to get x is equal to negative 3, since we are solving for x. And then the other one, x squared minus 4x plus 5 equal to 0. If I can't see the factors, I use the formula. So I'm going to have negative b, which will be positive 4, plus or minus the root of b squared, which is 16, minus 4ac, that will be 20 here, over 2. So it means that the only value of x that we have is negative 3. The other ones are complex and would have loved to have real. So this is how this one ends. So what's key in this class is, 1, knowing long division. When to use it. Use it where synthetic is not applicable. 2, synthetic, when to use it. Use it when you have factors. If you don't have factors, you cannot use synthetic. I mean, when you have easy divisors, which you can easily equate to 0 and get the values of x to use, because it depends on those values of x. If, for example, you are given that the divisor is x squared plus 4, you can't equate this to 0 for you to get the x to use, because this will come out as -4. You'll be getting the root of -4, which is a complex number. So it might be tricky for you to use a complex number in synthetic. So if I arrive at x squared plus 4, the best method to use is long division, so that you keep this side, and then you place whatever dividend you are given inside. You will get your quotient, you will get your remainder. So you should know when to use long division, when to use synthetic, how to factorize. These are the most key things. Is when to factorize, how to factorize, you need to get the values of x. Those values of x, once you find the one that gives you 0, then you go to synthetic. From synthetic, you have the reduced form that is that's the product, and then you reduce further the quadratic. Or if the power was 4, you have a polynomial that you need to reduce again using synthetic, then reduce now to quadratic, and then factorize to linears. If you are solving equating to 0, equate 0 and x and get the values of x in that simpler manner. Okay. So the next stage of polynomials is to sketch, to solve the inequalities, and to do the applications. Those 3 are only remaining ones under polynomials. So hope you are cool here. And 1120. NOC combine even 1100 and 1110. Oh, they don't reach that. Okay. So for 1110, you are safe. No inequalities. For 1120, inequalities are there. 1100, they are there. Okay, so I need to teach the second days now. We can carry on in the morning, since I'm now in the sack, and we are all able to wake up because of the test. So in the morning we'll finish polynomials. Then in the evening we'll come back and do the output and the nature of roots tomorrow. So by the time we are sleeping tomorrow, we would have finished. Only be remaining with revision that we'll do on Thursday and Friday.